Namaste. Myself Sachchida Nand, Assistant Professor, Department of Mechanical Engineering, Buddha Institute of Technology. Today we are going to discuss the structure of material, the key to its property, a multi-scale perspective. So, the structure of a material plays a very important role for making that particular material workable, and that workability of that particular material leads to its selection for making different kind of products. And why these properties are basically required. So, as we discussed earlier in class, that any component which we are going to make, that should be prepared as per their working environment. So, the working conditions. So, on behalf of that working environment and their working condition, the conditions which will apply on that particular component, as you can say, on the particular material. On that point, the properties of that particular material will start play their role. As we talked earlier about the various components or the transportations materials, like we talked about Titanic in the sea, we talked about maglev train. So now we focus on the maglev train that is running by the speed of 300 to 500 km per hour. So what kind of material we choose, that particular train, maglev train, will sustain the velocity, the speed of that particular working condition. So it is the material who sustain that particular working environment by fulfilling their properties requirement during the working operation of that particular component. And in the similar way, as we talked about Titanic, that particular Titanic was drawn. But why drawn? Because one property of that particular material was not examined, and that was examined after the drawn of Titanic, that is ductile to brittle transition of a steel. The tendency of the steel which work in low temperature water, that is the working environment of that particular steel, which was not tested before that. But after drawing of that particular Titanic, it was founded that that particular material's property should be enhanced, so that in future that kind of mishappening will not happen. So that is how the property of the particular material is required. As we talked about the maglev train, it is running on a very high speed. So first, who is facing that particular speed? Who just facing that particular speed of the wind? Who just facing the first coming of any particle in front of that particular maglev train? That is just of their material. And that material should have the property to sustain that kind of speed, such kind of impact, to maintain the workability of that particular material, to work and run in such a kind of speed of 300 to 500 km per hour. So as the other component also we are considering, that the properties is must required for any kind of material to perform during the working condition of any component and maintain the workability of that component in any kind of environment. So why we are need to study this particular structure of the material? Because the structure of material defines the properties of the materials. It is as simple as it is. We are affiliated or we are connected with some families, and the sanskar which we get from that family, we distributing everywhere and we are showing that. And that is how we sustain ourselves in this society at any circumstances. So on that perspective, this material should also. So as we talked about the properties, why it is required, so we discuss about the maglev train, we discuss about the Titanic, we discuss about the structures, various structures like bridges or like any small components or any small component which are working in the various environments. So that properties play a very vital role to maintain the stability or workability of that particular component in various environment. So on that behalf, the properties of a material is very important, and on that behalf, the selection of the material is taking place for making any kind of product. So that is how the sequence wise we are proceeding. That is why the selection of material is required for making any component, and due to just the properties, that property is related to the workability of that particular component, and that is how if we talk about the properties like if we talk about the property of the metal, we will discuss detail in the letter, but we talk about if we taking an example of that particular metal, so which are used for a particular like a bridge structure. So what are the working conditions over there that the particular material will sustain to work properly? It will sustain only when the properties of that particular material will fulfill the working environment conditions. Like if we taking an example of bridge, that bridge are in open system that will face winter, summer and the rainy season, that will change the temperature day by day, that will introduce some time of heat, some time of cold and some time of humidify environment. So if that particular steel will not have that particular sense or the property to sustain according to that particular working environment, so it will not work properly and the structure of that particular material will collapse before its lifetime. So that is how the material property is required, and it is need to be must study before selecting any kind of material, and that selection of properties, that the requirement of properties of that particular material according to the working condition of that particular component is to be made. And that's why we are studying that. That is how we proceed to make that particular material according to the working condition of that particular metal or the material for making any component to work in various environments without hampering the structure or any component. So for proceeding this, we are moving on the outline of this particular thing, the properties of the materials, what are these things which are related to, what are the different types of that particular materials, and then we are moving to how that particular materials taking shapes, the scale of microstructures, that how it builds from that micro levels, the crystal structures, that particular improvement of that increasing of that level of the structure, and then the defects, that defect, it's not that kind of that harm the particular material, that is defects, it leads to create or improve the properties of that particular material, the microstructure, that will compensate or manage the particular microstructure to improve the various properties, with example from the material world. So now we are proceeding. What is the property? The properties of a material is defined for any kind of material to work properly according to their working condition, and that is how the material selection takes place. The properties are divided into parts, that is the structure sensitivity and the structure insensitivity. As the structure sensitivity related to the yield stress, fracture toughness, and so on, and the structure insensitivity, that is related to the density, elastic modules, and so on. So these structure sensitivity and the insensitivity related to that particular selection of the material's properties, and that is structure related to the microstructures of that particular material, and according to that microstructure, the working condition of that particular materials is defined. So what determines the properties? It just cannot just be the composition. So we cannot say that just one component will define the various properties of that particular material. So can just be the composition. There is one question: only the composition will make that particular property of that particular component? No. The answer is not only that things only. Few tens of ppm of oxygen in copper can degrade its conductivity. If we increase that particular oxygen, you can say if somehow we increase that particular composition level, that will decreasing the particular property of that particular material. So it is required the exact amount of composition of that particular material to maintain its property well. So next question, cannot just be amount of phase present, that how much phases are present over there. A small amount of cementite along grain boundary can cause the material to have poor impact and toughness. So just including of that particular grain boundary, a cementite on their boundary, which loses their particular materials poor impact toughness. So cannot just be distribution of the phases, the dislocation can severally weaken a crystal structures, obviously. So cannot just be defect structure in the phase present, the presence of structure, compressive stress, toughness, toughen the glass. So these are the things which we need to consider. It is not only by the single things that we include that particular types of components in a certain percentage, and then the property of the particular material will improve. That is now how it works. So if we are going to make any kind of material, that material should have the properties according to their working condition, and that property should be maintained by these questions, that the composition, the phase present, the particular distribution of the phases, and the structure of the phases that is present in that particular material. So these all are the things, and more are than the things which define the various properties of the particular material. It is not just the one thing that we maintain the phase and that particular property of that particular material will increase. We need to maintain the composition of that particular material. We need to the distribution of the phases in an equal amount, and we need to maintain the structure of that particular phases and the distribution of that particular things across the total component of the material. And that structure, the phase present in that particular structure will define the various properties or enhance the various properties of that particular material. So that is how the property will improve, and that a better product is created by that particular thing. So as you can see in that particular the composition which related to the phases and their distributions, and the defect in the structure, and they release also, if we are not taking it seriously by maintaining all these things, that is related lead to also the residual stresses. So it is just like cooking cooking a meal, like if we increase the percentage of salt in some kind of, you can say, in the vegetable, or you can say food, then the taste of whole meal will change. Like if we are cooking some kind of a dal, that the dal need to include the turmeric powder, the salt, and some kind of spices, and the other things which make that particular dal tastable. But if we increase the percentage of the turmeric, the haldi, then what will happen? The total taste of that particular dal will change. So that is how the materials is also need to be taken care to maintain their proper particular properties. That is how it will work in that particular condition. So that according to that particular dividing of that properties, that is how that particular material will taking place, and that is the length scale involved, that is from the creating of that material from the nucleus to the atom, and that atom lead to the crystal structure, and then the microstructure. They combine with the the crystal structure combine, and then create a microstructure, and then this microstructure related to that particular component. And you can see there is a defect showing there. So that is in between that particular atom to the microstructure. That defect showing the arrangement of that particular atoms in that certain level of structure. We define the various structure properties of that particular materials, and that how the component will behave and the work. So that, as you can say, that it is started from the very small thing, that the unit cell, the combination of the atoms, the set of the atoms, that is at the very fine level of the meters, you can say that is 10 to the power minus 10, the angstrom. And the dislocation stress field nanometer, that is the crystalline defect, that is the defect in the crystalline level, that is the 10 to the power minus 8, 10 to the power minus 7, 10 to the power minus 6, 10 to the power minus 5. And that lead to the micro level, that is the grain size, which we can examine by a simple microscope with the magnification of the 10x or the 100x. You can say we can maintain it by, you can see by the help of that particular microscope. But if you need to examine at that particular level of the crystalline defect, we need to zoom this particular by the SEM and 10 machineries or the equipment, which will help to identify the structure of that particular material at the crystalline level, and that the component which is defined by at the particular centimeter level, that is 10 to the power minus 1, and then that is the 10, that is all are defining at the length of the scale, that is how the particular material are building, and the particular material can be analyzing at a various level of the scaling level. That is how we can examine the structure of that particular material, that how it is behaving and how it is working. So that is the structure, how it creating all these things. So starting from the nucleus, the atom, the structure, microstructure, and the component, and that structure is related to the crystal structure and the electromagnetic structure. That structure is defining the properties of particular started the building of that particular things, and that is how you can see the component which are made by the casting, metal forming, welding, powder processing, and machining. So these all are the manufacturing process by which the metal particular component are made, and that particular component are made by some kind of material, which material are as you can see, the casting is the process by melting of any component any material, and then cast it as the requirement of the particular component in the shape. After that, the metal forming is taking place, the changing the shape by hammering or by hammering of that particular steel, and if required, it is to be weld, or if it need to be required, the powder processing or in the machining processing, the component is to be made. So in all these particular manufacturing process, the properties of that particular material will play a very crucial role, as when we apply the various kind of processes in the cast. If you talk about the casting is the, you can say, is the total origin of that making of that particular component. Then we dissolve that particular component in like a water, and then they start solidify. So that solidification will take place from that particular beginning of that particular thing, as that is started from the nucleus and the atom, the crystal structure, the microstructure, and the component. So that particular thing, and that the casting is the very important manufacturing process to build any kind of a metal or any kind of a material, that defining the solidification and the making of any component is defining by that particular things. So again, moving to the metal forming, if we are going to that metal forming process, then again the metal is heating and the beating. The heating by in the furnace, and then when we heat the particular material, the structure of that particular component, the structure of that particular metal will deform again. Again, they will stretch themselves at a microstructure level. Then at the atomic level, they are stretching themselves, or you can say they are releasing themselves by the effect of the heat. And then we are hammering on that, then they taking the shape because of the hammer, and that is how they start the solidification, and that particular point they start solidification themselves and taking the place, and that is how that particular components are made. And if we talk about the welding, in the welding we are joining the two pieces by the help of the heat and the load which we are applying. So the collisions of the molecules, in between the collisions of the molecules, the joining of that particular material will happen. So that the collision is also related to that particular casting. And in that case also, the casting, as I said, the structure of the material started from the nucleus level to that component level. And in the similar way, in the welding also, the weld pool started solidify from the nucleus to the atomic level, and then the microstructure, then the atomic level to structure and the microstructure, then they combine all these things to create a component. So that is how the manufacturing process need to be taking care to creating any kind of component regarding utilization of that particular component in a specific way or at a specific place. So if we are talking about the powder processing, that powder processing is creating by the compacting the particular powder of that particular materials. That combination means that we have the kind of a powder which we are compacting in a certain die. That compactness will taking place, as you can say, the sticking of that particular component atoms or the nucleus in between, then they are creating a solid piece. So that is how that the atomic level and the nucleus level structure is taking place, and then the changes of that particular component properties are also taking place. And in the machining process also, there are lots of machining process which changes the structure of the component of that particular material. So if we are going back to that particular thing, the structure, the thermomechanical treatment and the microstructure of that phase and defect. So if we made that particular things, that we can change or improve or enhance, you can say, enhance the properties of that particular material, or by thermomechanical treatment. If we make any component earlier, and if we require to improve or need to decrease some kind of property of that particular material, or to enhance that particular property of that particular material, so we need to treat that particular by the thermomechanical treatment, that is called the heat treatment process also. That by heating or cooling that particular material at a certain temperature, and because of that temperature changes, the phases of that particular structure will start deforming. So and the defects are also taking place, which leading to the changes in the or enhancing the properties of that particular materials. So then microstructure plays a very vital role for improving or enhancing the properties of the material. If we change or alter the particular structure or the microstructure of the particular material, you can say the structure, if we change the structure at an atomic level, then the microstructure will start taking place, because it is connected with that particular thing. If it initiate at that particular level, nucleus level, at atomic level, then the whole scenario of that particular component structure will start reforming themselves. So again, that is the kind of a cyclic process by which we can change the tendency of that particular property of that particular material. So that is how the manually we are working on that, and nowadays the smart material can do itself by itself also, that if we require that particular material according to that situation, they are changed their structure and then they adjust themselves as a requirement of that particular things. So if we are talking about the material microstructure, the microstructure is related to the phases and the defects. Why it is required? As it is required, I talked that we have required to change that particular things by the means of that heat treatment process, the thermomechanical treatment, by which we are enhancing that particular phases and the defect inside available in that particular microstructure. So what happening when we are heating and cooling that particular thing in the microstructure? So the structure based and the property based changes. The structure based changes, that the crystalline plastic changes and the atmosphorous changes. The things is happening in particular material. So at a defect level, that is there's a lots of defect is happening in the particular materials. So that is the vacancy, dislocation, twin, stacking fault, grain boundary, void crack. So we can change or enhance these types of defects, and these phases also. These phases also we can maintain and to improve the various properties of that particular components. So that is how the phases and the defects of that particular metals are defining. So if we talk about that particular structures, the microstructure, it play a very crucial role to define the property of the material, that define the phases of that particular material. The structure based phases, that is the crystalline structure, that is quasi crystalline structure, the amorphous structures. So we define that particular structure into the three categories of that particular things. So in these categories we are changing that particular by that thermomechanical treatment, and we are enhancing that particular property of that particular material. And in the properties base, we are talking about considering these things, that is the ferromagnetic material, the ferroelectrical and superconducting material. So on that phase, this phase is divided in these particular structure based and the property based things, but these all are related to that particular enhancing the property of that particular material. If we changes the structure of the particular material, they start changing the property. Where we changing the phase of that particular material, that the level of that particular microstructure, and these microstructure related to the structure of that particular atom and the nucleus structure. So at the beginning, if we are enhancing or improving that particular thing, we need to consider that particular thing with that at atomic level. And if we are talking about that is related to that particular microstructure, the phases, the two phases, and that the defect lead to the structure, maintain the particular properties of that particular material also, and that defect also creating some kind of residual stresses which we are not properly maintain or make by taking place of the things which is happening when we are treating that particular things or making by this particular casting and another, that is the manufacturing processes. So these things we need to taking care regarding making any kind of products. So if we are making any product by various manufacturing processes or enhancing that particular product material by any thermomechanical treatment, we need to take care the base of that particular material, the originality of that particular material, to maintain its structure and to maintain its originality to behave according to its requirement. So as you can see, the residual stresses is also showing here. That residual stresses is just because of introduction of the defect in that particular structure, and that defect leading to that particular structure arrangement of that particular atomic level. So that atomic level arrangement, if we are not maintaining that in a proper way, the interatomic bonding of that or the free energy, or you can say interatomic energy, will lead to that particular stresses, and that stresses will lead to the failure of that particular component also. So avoiding the stresses concentration and the good surface finish, we need to maintain the component, and we need to maintain that phases, the defect, that heat treatment process and the manufacturing process in a proper way, that the properties of that particular metal is maintained, and then that the thing is to be taken care of. So that particular we talked about that the things, how that the things is happening, and you can say the particular microstructure is playing a very crucial role to maintain that particular structure of that property of that particular material, and that property related to the phases present in that particular metal and the defects which are included in that particular structure of the material. That structure including the various kind of defects like vacancies, dislocation, twin stacking, fault, and these defects is not kind of that defect that it harms the particular materials. It basically enhances that particular material. That defects lead to improving the particular material at atomic level, and that distribution improving the various properties of that particular material, and also structure, leading that particular structure at that atomic level. So these all are correlated to each other. By disturbing all one of them will demonize the particular properties or demonize the particular component. So we need to maintain all these things. So for regarding all this, we need to maintain the particular properties. So it is very necessary, if we are making any component and we are selecting that particular material for any making any component, we need to consider all these things for making the better product, better quality product to work in that particular environment. And these properties are not only a single word, these all are the whole system by which that component work in their working condition a proper way. So that all related from the nucleus level to that component level to related to each other, and that is a very deep knowledge of that things which we need to consider regarding making any kind of a product or making any material for any kind of component. So according to the requirement of the component, the property of the selection property of that particular material need to be fulfill the working environment of that particular component, and that is how we need to make a particular material workable according to the working condition of that particular component. So how we make that particular property in that, how we enhance or create that particular property in that certain kind of material. So by enhancing or by maintaining the structure at that, what kind of structure, the microstructure and the structure of the atomic level, that from the beginning of that atomic structure level, if we enhance from that or if we maintain that particular structure at atomic level, we reach to that particular property and we reach to that particular thing at a certain quality level for maintaining the particular property of that particular component as per the requirement. So we will discuss in later classes in detail what are the role of that particular structures and the microstructure and the phases and the defect plays a crucial role for making the better property of any component, and these all structure based the properties are defined by these particular structures, if we disturb this structure, we alter the property of the material. So we need to take care during making of any component that we do not harm or we do not change the originality or the requirement originality or you can say the arrangement of that particular microstructure. If we are changing that microstructure, we need to be alert that if we change that thing by any kind of processes like thermomechanical treatment, that is the heat treatment process, then we need to maintain the originality of that particular structure. If we totally disturb that structure, then the whole scenario of that particular material will change. So if we are enhancing or if we are making any kind of product, we need to take care the structure of that particular material and the phases and the defects which are available in that particular material need to be taken care of very precisely, that they maintain their property and that property which is worked by that particular component. And that is why we are saying that thing, that the main thing happened with that particular Titanic, where the material selected as per their working condition on ground level, not in the sea level, and when it reaches to the sea in the cold water -2 degree, then the structure of that particular, the phases of the particular structure of the material, steel, start taking place or a rearrangement of themselves, and then the rearrangement leads to them a brittle fracture, from ductile to brittle fracture, and that is how it collapses when it is struck with that particular iceberg and it's collapsed. So that is how it is very important to maintain and balance the property and the structure and phases and the defects which are involved in particular material need to be taken care. So we will discuss later in detail. So for now, thank you.